Okay, we are continuing with the 5.1 notes. So just a review about everything about graphs of a polynomial function. So if you have a question on something, you should go back to this and kind of read what does it say. So if it's looking for the range and you don't know what to do, go to this page and see what it says. So the appearance, it's just saying it's smooth. The end behavior is going to be from the degree of the polynomial and the leading coefficient. So when you take a look at the end behavior, remember there were 4 different types of end behaviors. You could have one that's going pointing up U-shaped, so that's an even positive. This would be an even negative, or you can have kind of a snake one, I call this. So this would be for an odd degree, and this would be a positive leading coefficient, or looks like this, which is an odd degree, but it has a negative leading coefficient. So again, it's the degree and the leading coefficient that's going to tell you the end behavior of the graph. The next thing is the x-intercepts, also called real zeros. So if it's in factored form, the x value of the intercept is the opposite of the inside of each factor. So I'm reading that second bullet point. What that means is if it's in factored form, you can use the zero product property, where you set each factor equal to 0 to find out what each x-intercept is. And then to decide at each x-intercept, I'm going to jump to behavior around x-intercepts. You're going to use the multiplicity to figure out what it's going to do. So the multiplicity is going to tell you, recall from our last set of notes, if it's going to bounce at the x-intercept, is it going to cross at the x-intercept, or is it going to cross and wiggle at the x-intercept? You also have to be able to find y-intercepts. Y-intercepts is when you let x be 0 and you're going to solve for y. Turning points, you need to know this formula. Turning points is equal to n minus 1. So it is the degree minus 1. That's it. And turning points are your maxes and mins. So that would be the max number that you would have. It doesn't mean that's how many you have, it means the max that you could have. Increasing and decreasing. So make sure you use x values when it's talking about increasing and decreasing. So that's when you're looking at the slope. You've done increasing and decreasing since semester 1. The domain is always real numbers. So you can pretty much just write that as this. And the range is lowest to highest. So if you remember that, that will help you write your range. So that's kind of an overview of everything that we've already done so far. So let's go ahead and take a look at some examples. So now we have this in factored form, which is a great form to have because you can find out what the x-intercepts are, also known as zeros. So these are like calling them the x-intercepts, right? Except zeros, you just say x equals, and x-intercepts are actually points, but the actual number is the same. So because it's in factored form, you can set each factor equal to 0. So you could say x plus 4 equals 0. So you would get x equals negative 4. And you could say x minus 1 equals 0. So you get x equals positive 1. Those are your zeros. You can't set negative 2 equal to 0 because there's no variable there. It says, what is the multiplicity of the rightmost real zero and the leftmost? You might be like, well, what is left and right? Well, if you were to graph this, it would have x-intercepts like we talked about at negative 4 and at positive 1. So just do left and right. This is the leftmost point. This is the right point. So what is the multiplicity of the right point? So the right point is when x minus 1. So this is the right point. And this is the left one. So the multiplicity there is 3. And the multiplicity of the other one is 2. And it wants to know what is the behavior at each of these. So if we look again at the rightmost one, which is the x minus 1, the x minus 1, what does it do? Because it has a multiplicity 3. Because it's odd and it's greater than 1, it's going to go ahead and cross and wiggle. Okay, so I'm going to cross out those options. Cross and wiggle is more exact. For touch means the same thing as bounce, in case you ever see that word. Touch means bounce. The next one says the graph of the x-axis at the right leftmost x-intercept. Take out this word right. So at the leftmost intercept, so we're talking about this one here. Remember this one here had a degree of, a multiplicity of 2. So it's even. So what does it do at even? It bounces. And then it says near the rightmost x-intercept, what is the end behavior of the graph? We are not going to worry about parts E. We are not going to worry about parts F. Okay, cross those out. All right. The maximum number of turning points of the graph is, I already told you above, if you look under turning points in that section, it's going to be n minus 1, otherwise known as degree minus 1. So if we decided that the degree, which we haven't written down, but if you add the 2 plus the 3 from the multiplicity, since the degree is 5, 5 minus 1 is 4. That's all you have to do. What is the power function? So the power function is going to be made up of, and we talked about this previously on other pages, it is the leading, your leading term. So for this one, if you multiplied this all out, it has to be in standard form. If you multiplied this equation out, which I'm not actually going to do, but if you kind of think about breaking it up, what would happen to the leading terms? You would get a negative 2 from here. This section here would give you an x squared. And this section here, if you multiplied out, it would give you an x cubed. So altogether, if you did multiply this polynomial out into standard form, your leading term would be y equals negative 2x to the 5th. Again, you don't actually have to multiply it out. If you just kind of think about what would be the leading term for each part, and then you put those parts all together, you will have your power function right there. Okay, so we're going to try that again with another example. So example 7, use the function to answer each part below. So once again, we're going to go ahead and find the x-intercepts. So you're going to go ahead and set each factor equal to 0. You're going to use the zero product property. So we've got 2x plus 1 equals 0. That's going to give us minus 1 divided by 2. And you also have x minus 3 equals 0, which is going to give us x equals positive 3. So the x-intercepts, and since they ask for intercepts, I'm going to list them as points, are negative 1/2, 0, and 3, 0. If they ask for zeros, I would just say negative 1/2 and positive 3. Find the y-intercept. The y-intercept is when you plug 0 in for x. So I'm going to go ahead and plug 0 in for x, and I'm going to use my calculator to do this for me. And when I do that, I get a y value of 9. So the y-intercept is 0, 9. So it says, what is the multiplicity of the rightmost real 0? So once again, if you want to graph this, we have, and the zeros are talking about your x-intercepts. We have negative 1/2, which is here. And we have 3. So we have x equals 3. We have x equals negative 1/2. So this is on the left, and this is on the right. So if I go back and label that in my problem, because it just helps keep me organized, this is the right, this is the left. So what is the multiplicity of the rightmost? The rightmost is the x minus 3. Its exponent is a 2. The leftmost, when there is no exponent, that's just an exponent of 1. What does it do at those spots? So at the smallest x-intercept, also known as the left one, so when x was the negative 1/2, it had a degree of, it had a multiplicity of 2. It had a multiplicity of 1. If we look here, and because of that, that means it's just going to go ahead and cross. Again, that's because the multiplicity was 1. The largest x-intercept, which was a positive 3, what did it do? Well, its multiplicity was 2. It's even. And whenever its multiplicity is even, it's going to bounce. Again, you can also call that touch. What is the power function? So again, imagine if you were multiplying it out. What you would have is 2x from the first factor. The other one, if you multiplied it out, you would get a leading term of x squared. So if you put those both together, that's going to give you y equals 2x cubed. The maximum number of turning points is degree minus 1. So our degree is 1 plus 2. You can add up those multiplicities. So 3 minus 1 is 2. So that would be the most max or mins we would have. What is the behavior? We're going to skip those because we're going to show you in the graph. So we're going to go ahead and graph this now. Remember, you have to label your numbers if they're not counting by ones. I have to see tick marks, okay? So I'm going to start by putting in the x-intercepts here. So I'm going to go ahead and first label. This is going to be 1. Then we've got 1, 2, 3. And I found my y-intercept is located, what did we say, at 9. So I'm going to just mark this as a 9. And I'm going to start graphing my points. This is a y-intercept. We have an x-intercept at -1/2, and we already discovered at the -1/2, it's going to cross. So I like to put a C above it. At the +3, it's going to bounce. So I like to put a B above it so it reminds me what it does there. Now the end behavior. So if we think about the end behavior here, remember that the degree of the entire thing is 3. So it's odd. And the leading term from the power function is a 2 here. So it's a odd positive. So if you think about your 4 graphs that you would have, it would be this one. So that's going to be your ending. So you're going to draw the end arrows to it. We know that it's going to end like this. And now we have to go ahead and draw the middle. So that was all the given information. And now we're going to go ahead and draw the middle part. Okay. So as I'm following my arrow, it has to cross through here. It's going to go through 9, but it has to come back down. Why? Because it has to hit that other x-intercept. So somewhere there's a max. We don't know where the max is, and that's okay. But it's got to come back down, and when it comes back down, it has to bounce here. Those should be connected. And again, that's why I like to label it so I know what to do. And then the end behavior matches up perfectly. So that is my graph. All right, we're going to do some more practice. The next one on page 7 is talking about with your graph on your calculator, which we will get back to in a second. I'm going to go ahead and cross this problem out though. We're going to go ahead and continue on with the factored form and do page 8, and then we will go back to page 7. So we're going to continue with the factored form. So the next one says form a polynomial whose zeros and degrees are given. So if we know the zeros, you can write this in factored form. So if the zeros is -1, you can write that as x plus 1. So you can just write the opposite, the factored form. If it's +1, you can write that as x minus 1. And if the other 0 is 8, you can write that as x minus 8. It says the degree is 3. So if you look at these exponents, on the multiplicity for each one, that's 1 plus 1 plus 1, which does give you a degree 3. So that is my polynomial. That could be one of your answers. If it doesn't specify a form, that would be fine. This is considered your factored form. Just to get some practice in, I'm going to have us multiply it out to get into standard form. So if you were going to get into standard form, you would have to go ahead and multiply 2 out of 3 of the polynomials. So if I multiplied x plus 1 times x minus 1, and I simplified, that would give me x squared minus 1. And then if I brought down the x minus 8, and I did that again, so now you would have to multiply these 2 polynomials. That would end up giving you x cubed, so I'm foiling here, minus 8x squared minus x plus 8. So that would be the answer if they wanted it in standard form. So we're just practicing both. If it doesn't specify, I would do factored because that's, you're not going to have any, you won't make any errors then. Okay, the next one for the zeros. We've got 0, 2, and -5 and degree 3. So since there's 3 zeros and it's degree 3, they're obviously all going to have exponents of 1. So let's go ahead and take a look here. So f of x equals, since the 0, 1, I would not write this as x minus 0. Simplify that. X minus 0 is just x. For the positive 2, you're going to write that as x minus 2. And for the -5, you would write that as x plus 5. Again, this degree is 1, 1, and 1. 1 plus 1 plus 1 gives you a degree 3. So we're all good for the degree. We've got our zeros. And again, this answer would be acceptable. You don't even have to put the ones if you do not want to, because technically you do not need them. But if it does want the standard form multiplied out, I'm going to go ahead and have you practice that. So right now I'm going to have you stop. And I would like you to go ahead and to multiply that out and give your answer in standard form. All right, welcome back. Let's go ahead and see if you have the right answer here. So I would first go ahead and multiply these two. So that would give me f of x equals x squared minus 2x. If you multiplied the other two, that's okay. You can still get the same answer at the end. And now I would go ahead and multiply out, FOIL these two pieces together. And when I do that, I'm going to get x cubed plus 5x squared minus 2x squared minus 10x. So this one does have terms that I can go ahead and combine. So I'm noticing that these are like terms here. So my answer would be f of x equals x cubed plus 3x squared minus 10x. Again, that would be the standard form. So if it specifies, you need to multiply it out. If not, that factored form will work, because they mean the same thing. All right, let's go ahead and take a look at the next portion here. So now they've given us a graph and we're going to end up writing the equation, okay? So the first thing you have to do is find your x-intercepts. So let's go ahead and find those x-intercepts here. We've got one at -6, one at 0, and one at 7. And look at what happens at the -6. It bounces. Look at what happens at the 0. It crosses. And then at the 7, it goes ahead and it crosses as well. So that is important. The end behavior is also important when we're going to end up writing this, okay? The equation at the end. In factored form will be acceptable. So the zeros, we have 3. So we have x equals -6. We have x equals 0, and we have x equals 7. At the -6, we have a multiplicity because it bounces. The multiplicity has to be even. So I would go ahead and probably list that as 2. I would list the lowest one. When x is 0, it crosses. So since it crosses, that means that its multiplicity, because it does not wiggle, is going to be 1. And for the next one, same thing. It crosses through that part, so its multiplicity is going to be 1. Which makes sense because if you add the multiplicity 2, 1, and 1 together, that gives you 4. And notice that the degree is 4. So that would be the correct answer. So the degree here again is 4, either by your graph or from literally looking here. The leading coefficient for this problem is going to be, you can literally look here, it's going to be a positive x. The leading coefficient is +1. And because of that, it's a positive, and the degree is 4. So think of this, that it should be a U shape for the end behavior. And notice that the end behavior here is in fact a U shape. Right, there's my end behavior, there's my end behavior. They match up. So now we're going to go ahead, now that we've checked all those things, and write our equation in factored form. Since we know our x-intercepts, x is -6, we're going to write that as x plus 6. It bounces, so it's squared. We also have x equals 0. I'm going to put that in the front. That's just an x. Whenever x equals 0, it's just an x. And its degree is 1. And then we've got a positive 7, so I'm going to write that as x minus 7, and its degree is 1 as well. And we're going to leave our answer exactly like that. We are done. All right, we're going to try that again together. This time they did not tell us the equation, but they gave us just the graph. You can still go ahead and figure out everything here. So we've got some x-intercepts here. We've got 4 of them this time, okay? So this is located at -4. And notice that it crosses here. This next one is when x is -1, and notice that it bounces. This next one is 1, 2, 3, 4, when x is 4, and notice that it crosses. And this next one is when x is 6, and notice that it crosses. And then the other thing to note is the end behavior. What is the end of the graph doing? And we should be able to write the equation from there. So again, our zeros are where they cross the x-axis. So x equals -4, x equals -1, x equals 4, and x equals 6. The multiplicity, if it's even, go with 2. If it crosses, it's 1. If it crosses and wiggles, it's going to be like 3. So for x equals -4, it crosses, so it's going to have a degree of 1. When x is -1, it bounces, so the degree is even, so we're going to put 2. When x equals 4, it crosses, so it's going to have a degree 1. And when x is 6, it crosses, so it's going to have a degree 1. And again, I went with the least degree. So for instance, that even one, that's 2. I didn't list 4 because I want the least degree possible. The number of turning points is degree minus 1. So for this example, our degree is 2 plus 1 plus 1 plus 1. We've got 5. So 5 minus 1 is going to give me a degree of 4. And the least degree possible there is 5. The leading coefficient, we don't know exactly what number it is, but we can tell if it's positive or negative. Again, because of the shape of the end behavior, that is going to be for a leading coefficient that is negative. It's going to have a degree that's odd, and its leading coefficient is going to be negative because it looks like this, right? Again, you look at the end behavior of it, not the middle of the graph, the end behavior. We don't know the actual value, so negative is enough. So our equation, since it starts with a negative, and again, we don't know the number, sometimes you'll see people put an A here for the unknown, but I'm just going to put a negative. And for our x-intercept of -4, I'm going to put x plus 4, multiplicity 1. When x equals -1, I'm going to write that as x plus 1. The multiplicity is 2. For the next one, for x equals 4, I'm going to write that as x minus 4. And the multiplicity is 1. And then finally, x minus 6, and the multiplicity is 1. I'm going to leave it like that. I do not feel like multiplying that out. That looks great. Okay, so if we continue to take a look. Okay, so if we take a look, we're going back to page 7. So we're back to page 7 now, since we just finished that page 8. So again, back to page 7, where we're going to be using our calculator. So go grab it if you don't have it, but you definitely need it. And you're going to start by, well, the first 2 boxes here, I have already explained to you in notes. We've already talked about how to find an x-intercept, which is the same thing as finding zeros, but it goes through everything. It talks about, you know, pressing second trace and number 2, left bound, right bound, guess. It goes through all that. Turning points, it goes through how to find turning points, same thing. You go into that second trace, left bound, right bound. Remember, turning points are just max and mins. Okay, so you have to know if it's a max or min when you're actually doing it. So those are the directions. I'm going to talk you through this problem. We'll do another one in class, but I'm going to start by typing in that y equals. So right here, you should be typing in the y equals exactly how it has listed. Okay, and if you ever have an error, you're going to have to talk to me so that I can help you work through it. Your plots should never be highlighted. Sometimes that's the problem. So you'd have to arrow up to them and press enter. You never want them to be highlighted. Okay. All right. So if your graph is kind of looking funky, always try Zoom 6. And hopefully your graph should look like this. you should be able to see everything, okay? So always sketch it. That's going to show me that you actually know what your graph looks like. And I don't know exactly what my x-intercepts are yet. I will calculate them, but this is my graph. I've got 3 x-intercepts on this graph. Okay, I need to answer some questions. So first, what is the degree? The degree is going to be 3 because it's in standard form. You only add them up if they're in factor form. What is the power function? The power function is that leading term, so y equals x cubed. And then we're going to go ahead and find the x-intercepts. So this is where you're going to have to use your calculator because it's in standard form. If it was in factor form, you could do this on your own. But we need the calculator in standard form. So again, this is what it looks like. You're going to go into second, calculate. We're going to be calculating a 0. X-intercepts are zeros. There's 3 of them. So if you look at this graph here, if I'm going to start by finding the x-intercept here, and I'm going to write this down and then erase it. So this would be when I do my left and my right bound. To the left, which is this way of the point, is below for this problem. The right bound, which this is to the right, you're going to have to move your cursor. The right is going to be above for this one, and then guess would be right here. So if I go ahead and I do that, I'm going to do left bound, hit enter, right bound, hit enter, and guess, hit enter. I should get negative 2.16. So again, I'm going to show you that. So I'm calculating the 0. Left bound would be below this one, enter. Then it says right bound, you're going to go above and then hit enter. And then guess, just go somewhere close to it. That's even fine. Hit enter. And it says x, or it says 0, x equals negative 2.16. Mine says in E, that means 0, okay? Some of yours probably will just say 0. It depends on the model of your calculator. You're going to have to do that 3 times, okay? Oops, I just lost my x-axis. Because there are 3 x-intercepts here. So you're going to have to do that 3 times, okay? When you do the next one, the left bound is going to be to the left of it. So this time your cursor is going to need to be somewhere up here. And the right bound would be here. And the guess would be here. For the third point over here, the left of it, so your cursor to be the left of that third point, so this one right here, this would be somewhere to the left your cursor needs to be is below. This would be somewhere to the right, and then your guess would be right here. Okay, so once you calculate those, you should get negative 2.16, and since it says list them as x-intercepts, I'm actually going to go ahead and change those to actual points. So we should have negative 2.16 comma 0. The other two should have given you 0.8 comma 0. You should try those. And 2.16 comma 0. To find the y-intercept, it's very, very easy. You don't have to calculate it. I'm going to add this section right here. To find the y-intercept, you're going to hit trace. And then you're going to type in 0, which it says x equals 0, and that's what a y-intercept is, enter. And it tells you, so you're going to do trace, then you're going to hit 0, and then you're going to hit enter, and it will tell you what your y-intercept is. In this case, and I'm reading exactly from my calculator, notice it tells it on the bottom, is 0, 3.73248. Determine the intervals where the graph is above the x-axis. If you are above the x-axis, that's this portion of the graph. That is considered above the x-axis. So we're going to do this in terms of axis. So this is going to be from this x value here, remember was negative 2.16, this x value here was located at 0.8, and this x value here was 2.16. So it is above between these two values. So the first thing is it is above the x-axis from negative 2.16 comma 0.8. That is not a point, that is an interval. Union, it is also above the x-axis on this section. So the x value is from 2.16 until infinity. It is below. Below would be this portion here. It is below that x-axis. So there's two segments, so you're going to have two answers here. So it is below from negative infinity, this part, up to 2.16, negative 2.16 that is. Union, it's also below right here, which is between what two x values, 0.8 to 2.16. Again, those aren't points, those are intervals. Find all turning points. Turning points are your max and mins. We've been doing this since semester 1. This one has a max and a min. So if you look here, this is going to be its max. And if you look here, this is going to be its minimum. So turning points are your max and mins. That's what you need to go ahead and find. So I'll go ahead and do one of them. I'm going to do the maximum. So I'm going to go to second calc. And I'm going to go to option 4 for this one, because that's my maximum. I'm going to do my maximum, and it's going to ask me left bound, right bound, guess, the same 3 questions. This time, the left bound of the maximum is to the left, which is over here. Your cursor should be over here. Your right bound would be over here, because that's to the right of the max. And then your guess is get somewhere close to it. So somewhere around there. So I'm going to do that in my calculator. So left bound, I'm going to move my cursor somewhere over here. I'm going to hit enter. Right bound, I'm going to move my cursor somewhere over here. I'm going to hit enter. Guess somewhere near the top of that hill, hit enter. So 3 questions, and then it tells me my maximum is x equals -1. I'm going to round to the nearest hundredths, so 2 decimals. So -1 point, I know it's 1.0086. I'm going to round up because of that. And my y value is 6.598. So I'm also going to round up to 6.60. You would do the same thing to find the minimum, except for the minimum, left bound would be over here. Right bound would be over here. And your guess would be somewhere close to this. Okay, so you would do that on your calculator, answering those 3 questions. And your point that you should get, which you should try, should be 1.54, -1.70. So that's your max and your min. From those values, you should be able to describe where is it increasing and where is it decreasing. So I'm going to go ahead and alter this to put my x values, because again, your increasing and decreasing should be in terms of x. So the x values at those locations are, this x value was -1.01, and this x value, so if you traced it down, if you traced it up, would have been 1.54. So increasing is going up from left to right. So if we take a look, it's going up these 2 sections here. So that very first section is from, again, you're listing the x's from left to right is -infinity up until -1.01. Union, there's that second part I highlighted. The x value is 1.54 and it keeps going to the right, so it's to infinity. Decreasing, there's only one decreasing section, and that's in the middle. It's going down from left to right here. So I'm going to list that between the 2 x values, -1.01 to +1.54. The domain for this one, very simple, is entirely left to right. So it's -infinity until infinity. And the range of this entire function, lowest to highest, again, is -infinity until infinity. So we'll practice that again in class, and I will see you then.